Now we look at the WAN devices, and there are many types of devices that are specific to WAN environments, to wide area network environments. To begin, we have the voice band modem, which is responsible for, which is used, which uses telephone lines. It's a legacy device. Okay, the voice band modem. This is basically a device that converts digital to analog. Our telephone lines, they probably use analog signals. So the modem converts digital to modem to analog. And I think by definition, a modem is a device which converts one type of signal to another. All right. So the voice band is basically converting the digital signals to analog so that they can be transmitted over your telephone lines. Then we have the DSL modem or the cable modem, collectively known as the broadband modems. These high-speed digital modems connect to the DTE router using Ethernet. So those two, they they're almost the same as the voice band modem in the sense they convert digital to analog, but these ones they work at much higher speed than the voice band. The DSL and the cable modem, much higher speeds. And unlike the voice band modem, which uses single channels, DSL, it can have multiple channels. So with the voice band, if someone picks a call, nothing else happens. No one else can pick another call. No data can go through that line. But with the DSL, you can have someone picking a call at the same time using the internet. So those two are a bit different in that manner, but they all use the telephone lines, except for the cable, which uses, I think it's coaxial. I'm not familiar with the cable modems in Zimbabwe. I know of cable TV. I've seen it in the movies. I'm not so sure in Zimbabwe, but it uses coaxial instead of telephone lines. Right. Then we have the CSU, DSU, digital list lines. They require a CSU. It connects a digital device to a digital line. So the CSU, DSU, is what we call a channel service unit or a data service unit. And it's a modem. You end up private school. It's a modem, it's a high-end modem which conveys digital data between different formats. So if we have, for example, we are going to discuss list lines T1, E1, T3, E3. There is a modem which is responsible for going from Ethernet to the type of data which can be transmitted over those T1, E1 links. So that is our CSU. It's a high-end modem. It's a modem basically, but high-end. Right? Our optical converters, they connect fiber optic media to copper media and convert optical signals to electronic pulses. Not much there. Then we have our wireless router, our access point. I think we are familiar with those ones, used to connect wirelessly to a wide area network. Then our WAN core devices. These are mainly multiple high-speed routers and layer 3 switches that makes up the wide area network right here at the core. So we have a number of switches, then a number of media connecting from the WAN to our CPE. From here, I can see this is a serial link. Okay, list line, serial link, same thing. This is a fiber link. This is wireless. This is cable. This is DSL, telephone lines, voice. Okay, so these are the devices that we have. Serial communication. When we talk of serial, one after the other, almost all networks, almost all network communication is okay using serial communication. It transmits bits sequentially over a single channel. In contrast, parallel communication simultaneously transmits several bits using multiple wires. So with serial communication, one wire, parallel, we have multiple wires. Evidently, you can see parallel, I think it offers more data rate, if I can say, more information is transmitted per unit second because of those multiple lines. However, only for short distances. Only for short distances. And I think that is why mainly serial communication is recommended because parallel is not reliable. Okay, as the cable length increases, the synchronization timing between the multiple channels become more sensitive to distance. For this reason, parallel communication is limited to very short distances. I remember application for parallel communication applications. I know many for serial, all the communication or networking is serial. Parallel, okay, I cannot think of applications right now. But I remember printers which used parallel communication. Um, okay, let's go. Second switched communication. Right, a second switched network establishes a dedicated circuit or a channel between the endpoints before users can communicate. So, one operations, we have two types of switching, circuit and packet. Starting with circuit. Basically, circuit involves a dedicated circuit and it is ideal for real-time communications. Why? Because it offers low latency and more bandwidth, if I can say. But it has problems because it is very inefficient. Once you have a circuit, you have a dedicated circuit, even if no one is using it, you still have a dedicated circuit. So it's costly and very inefficient in that manner. However, low latency, more bandwidth. Right, two types of circuit switch technologies that we have, PSTN and ISDN. We're going to look at both of those, I think, in later slides. But PSTN, I think this is the core of all networks, PSTN. If we're talking Tier 1, for example, almost every other network in Zimbabwe rides on Tier 1's PSTN infrastructure. Of course, it's being improved, removing copper wires, probably replacing with fiber. But the PSTN is what was there before everything else. Then the ISDN is sort of an improved PSTN. I think we have separate slides for PSTN and ISDN. So circuit switching dedicated. So for example, between A and B, you can see the dedicated link is this one. Via here, we go there, we go there, we go there. If that link is opened, it's only dedicated for communication between A and B. And like I said, it's very inefficient. Right. Packet switching. With packet switching, it involves data segmentation over a shared network. So instead of having a dedicated network, data is segmented, then it is sent through multiple links. On arrival at the destination, sequencing happens, then retransmission, if the segmented packets are not received, retransmission, then we have our data transmitted. Right, so the difference between these two, with circuit, dedicated link, with packet, it's a shared medium. So it means, for example, if I'm going from server 1 to server 2, some information goes through here. I think we only have one path. That's the problem. If we had multiple parts, I think it would be much easier to explain. We don't have multiple parts there. Okay, but I think it's good to understand this one use shared medium. It's not only, okay, I think I can put it this other way. Let's say we have server one here. We also have server two here. Let's call server three because server two we have it already. On this side, server one and three. If they set their information, this link, instead of being used only by server one, it can be used by server one and two. It's now a shared medium. So all our packets go there segmented, they travel over the shared medium. When they reach to their destination, they are rearranged and packet switching value. Much less expensive and more flexible. And the common type of packet switched WAN technologies, we have the Ethernet WAN, MPLS frame relay, and ATM. So with circuit, we have PSTN and ISDN. With packet, we have Ethernet, more MPLS, frame relay, and ATM. All right, SDH and SONET, DWDM. So all these are standards which are used in fiber communication. I think SDH and SONET are the same. The only difference is one is used, it's a North America standard, and the other one is used globally, SDH. So SDH Sonnet defines how to transfer multiple data, voice, and video communications over optical fiber using lasers and LEDs. So like I said, these are standards used in fiber. It's the same thing. The only difference is one is used in North America, one is used elsewhere. Then DWDM multiplexing. So this one, instead of having a single stream of data, we have multiple streams. Wavelength division multiplexing. We have multiple streams, and then they are multiplexed, greatly improving the bandwidth of our systems. Basically, that is what DWDM is. All right, let's move fiber. Right. Here we now start with our traditional WAN connectivity options. Traditionally, what was being used to connect different local area networks. So what was used, we had dedicated list lines. We still use them, by the way. T1, E1, T3, E3. All right. I think T carriers and E carriers is almost the same thing. The difference again, one is used in Europe and the other one is used, I think it's North America as well. But they define the capacity of the links that we have, that they had at that time using copper. I think the other one was 1.5. The other one was 43 for T1 and T3. So those are list lines. Those are copper links. And T1, E1, T3, E3, they basically define the capacity of those links. So if the capacity is 1.5 megabytes per second, it's T1. I think there's another slide for that. So traditional WAN connectivity options, we had the list lines, which were dedicated. Then for switched, circuit switched, and packet switched, I already introduced PSTN and ISDN. Then we have frame relay and ATM. All right. Common WAN terminology. Okay, there we have our list lines, the T carriers and the E carrier. T carrier, there are two systems used to define the digital capacity of copper media serial link. T, used in North America, T carrier provides T1 link supporting a bandwidth of 1.544 megabytes per second. T3, 43.7 megabytes per second. E carrier is used in Europe. E1 links supporting 2.048 and E3 supporting 34.368. I'm not so sure which one is used in Africa, but it is what it is. Common WAN terminology, advantages of lease lines. Simplicity, quality, availability. Point-to-point communications require minimum expertise to install. The links are usually offer high quality of service if they have adequate bandwidth. If they have adequate bandwidth. I think that's another disadvantage as well. What if they don't have adequate bandwidth and it's still fixed? It means it's not flexible. All right. If as a company, sometimes you have huge amounts of traffic, huge amounts of data being transmitted, and your capacity is fixed with the lease lines. That's a problem. So it's not flexible. If you have enough bandwidth, I think that's an advantage. But if not, that's a disadvantage. Right. Disadvantage is another one is cost. Point-to-point links are generally more expensive. The cost of lease line solutions can become significant when they are used to connect many sites over increasing distances. WAN traffic is often variable and lease lines have fixed capacity, so the bandwidth of the lines seldom matches the need exactly. So that's another disadvantage. Right, second switch options. We now discuss PSTN and ISDN. What is that? So circuit switch connections are provided by PSTN carriers. The local loop connecting the CPE to the CO is copper media. Okay, so there are basically two types of circuit switched options that we have, the PSTN and the ISDN. And they are used for voice and data communications over our traditional telephone lines, which is the copper media they are talking of. Right? PSTN uses the analog technology, which offers much lower bandwidth than ISDN. ISDN, on the other hand, it uses digital. So PSTN is analog. Over the same telephone lines, PSTN uses the analog technology. That's why it has a lower bandwidth. Then ISDN is a bit more advanced. Over the same telephone lines, we are now using digital technology. So it means we now have higher bandwidth because of that small change. Right. ISDN also offers a unified platform. I think we talked of converged networks which are able to transmit video, voice, and images. Yes, ISDN is able to do that. It has a unified platform which is able to transmit over the same link. PSTN is a different case. Right, so those two circuit switch options, they have a common ground. They use the telephone lines copper. The only difference, one uses analog, the other one uses digital. And the one which uses digital is a bit more advanced, more bandwidth. And I think that is the one which is currently being used at the moment instead of PSTN. But PSTN is the ancestor of networking. That is where everything began with PSTN. Right, packet switch options, frame relay, ATM. I think you notice, I think the word legacy here highlighted. Legacy. Is it the same thing as traditional? I think legacy means ancestors, dead, no longer being used that much. These are legacy technologies. Frame relay. I think they are being used, but they are no longer being used. Frame relay and ATM. What are those? So these are legacy packet switch options, and in frame relay, we have data being segmented to frames. Frames, then there is a virtual circuit which is created, and frames are transmitted over that virtual circuit. When we talked of packet switching, we introduced the word segmentation. So data is segmented. So with frame relay, data is segmented into frames, and those frames are transmitted over multiple PVCs, permanent virtual circuits. That is frame relay for you. And frame relay creates PVCs which are uniquely identified by a data link connection identifier. All right, with ATM, how are they segmented? Let me see. ATM technology is capable of transferring voice, video, and data through private and public networks. Okay. It is built on a cell-based architecture rather than on a frame-based architecture. So this one, instead of having segmented frames, we have segmented cells, which are also transmitted over a virtual circuit. So I think if you see the common ground between these two options, although legacy, the common ground is data is segmented. The other one uses frames, the other one uses cells. Right. Note, frame relay and ATM have been largely replaced by faster Metro Ethernet and internet-based solutions. We'll look at Metro Ethernet, I think, with the modern WAN connectivity. So to summarize, the traditional, including the legacy, we have the dedicated list lines T1, E1, E3, T3. We have the circuit switched connectivity options, PSTN and ISDN. We have the packet switched, frame relay and ATM. And most of them, they are legacy. They are no longer being used. They are being replaced by faster, more efficient connectivity options. With the modern ones have more connectivity options. Enterprises now require faster and more flexible WAN connectivity options. Traditional WAN connectivity options have rapidly declined in use because they are either no longer available, too expensive, or have limited bandwidth. PSTN, when originally designed, it was only for voice. It was only for voice. I think voice is 3 kilohertz. I think so. Right? But now we have streaming, which can go up to a gig when you're streaming. How can you have that much information over the capacity of PSTN, which was designed for voice? That's why we now have those things being replaced by modem wide area networks. Right? The figure displays the local loop connections most likely encountered. So I see cellular, wireless, satellite, coaxial cable, telephone, optical fiber. We'll discuss those in later slides. Let's go. Modern WAN connectivity options. What do we have? We also have dedicated, I think it's the same thing. We also have dedicated switched, and add to that, we now have internet-based connectivity options. With dedicated, we have what we call dark fiber. So when fiber was introduced, I think my companies are layer fiber, right? Tier one being one of them. A lot of fiber all over the country is there. But there was a new thing which came with wave division multiplexing, DWDM, right? One link of fiber, you will now be able to transmit multiple wavelengths. It means more data for that single strand of fiber. But fiber ikalewa ine ma-strands hobo, 120 something, right? It means instead of using all of them, only a few of them are being used because we're now able to multiplex our information. So as we speak, there is what we call dark fiber. Fiber which was left unused because of technologies like the DWDM. And big companies are using that unused fiber. Basically, that is what we call dark fiber. So it is now being used for dedicated broadband. Right, fiber can be installed independently by an organization to connect to remote locations directly together. Dark fiber can be leased or purchased. So our tier ones are now leasing that dark fiber. It's very expensive actually. I'm not so sure why. It's unused fiber, but it's very expensive. That is dark fiber dedicated. So with the traditional ones, we had our T1, E1 links, but here we have dark fiber. Right, with the switched connectivity option, we have Ethernet 1 and MPLS. So packet switched, all of them, they are packet switched. We no longer have circuit there. Metro Ethernet is replacing many traditional WAN options. Then we have MPLS, enables sites to connect to the provider regardless of its access technologies. All right, MPLS is very interesting out of these ones. All right, basically MPLS, what is MPLS? Right? And I think its name explains itself. Multi-protocol label switching. Multi-protocol label switching. So instead of having IP addresses, right, with an IP network, when you are routing, you use IP addresses. You look at the routing table. I think this is a more reliable route. We're going to choose this one. To get to that network, we use this IP address, the network address. That is how the IP network works. With MPLS, instead of having those IP addresses, we have labels. And those labels, they are much smaller than the IP addresses. And that means instead of looking up the routing table, it's much faster using those labels. Less time is used while trying to look for routes. And all other protocols, they can be encapsulated using those labels, meaning you have different, can I say different? You can have communication between devices using IPv4, for example, and other devices using IPv6 because all of them, they're encapsulated with the labels. So MPLS, multi-protocol label switching, very interesting. I think there is a dedicated slide for this one. But I think things to note, one, it uses labels instead of IP addresses. So their labels, traffic is encapsulated with the IP addresses in the IP network, then the labels in the MPLS network. Internet-based broadband organizations are now commonly using global internet infrastructure. So with internet infrastructure, we have wired, wireless, we have our DSL, cable fiber, Wi-Fi, municipal. I don't think I've never seen that one or use municipal Wi-Fi, cellular, satellite, UMASCs. Then we have WiMAX. All right, let's go. Ethernet 1. Okay, 4 more slides. Ethernet service providers now offer Ethernet 1 services using fiber optic cabling. All right, when we talk of Ethernet, even when we say the Ethernet cable, I don't think when we started, we pictured an Ethernet cable with a fiber. We pictured an Ethernet cable with twisted pair and RJ45 on the other end. That was our Ethernet cable. And when Ethernet was introduced, that was the thing. Okay. But, excuse me, but there were improvements which were made. Instead of using copper, we have other standards of the Ethernet which uses fiber. I cannot remember those standards from the top of the head, but we have standards. Instead of using copper, we have standards of the Ethernet which uses fiber. So now with copper, we are limited distance-wise, 100 meters, right? Local area network. With fiber, we are no longer limited with the distance. It means we can now use Ethernet standards, that is Ethernet 1, for much longer distances, just because we're using fiber, right? So with Ethernet 1, it's basically Ethernet using fiber instead of Ethernet using copper, which is limited with the distance. Um, the Ethernet 1 service can go by many names, including Metropolitan Ethernet, Ethernet over MPLS. Then we have Visual Private LAN service. There are several benefits to an Ethernet WAN: reduced expenses in administration, easy integration with existing networks, and an enhanced business productivity. I think I'll explain advantage number two, and advantage number three. So if your local area network is made up of Ethernet, it's an Ethernet local area network, it's very easy to translate that Ethernet local area network to an Ethernet wide area network. And that explains easy integration. If, for example, you have an Ethernet LAN network, then for a wide area network, you have frame relay. That's a problem, especially with encapsulation. How do you encapsulate your data to go from Ethernet to whatever which is being used with frame relay? It's very difficult. More so with applications which uses IP. How do you then translate that into another technology? Frame relay or your ATMs, for example, is very difficult. So that explains easy integration and with enhanced business productivity. Instead of having much of your time configuring a network, when you transition from an Ethernet LAN to Ethernet WAN, is very easy. So less time used in configuration, more time in productivity. Ethernet WANs have gained in popularity and are now commonly being used to replace the traditional serial point-to-point frame relay and ATM WAN links. That's Ethernet WAN for you. I think the most interesting thing I've seen about Ethernet WAN is Ethernet is not only copper and twisted pair and RJ45s. So possibly the cable we call the Ethernet cable is not only that one we connect to our laptops. There is also fiber, which is called an Ethernet cable as well, I might figure. And it is used for Ethernet WAN. Interesting. All right, MPLS. All right, I've already introduced MPLS. It uses labels. It's a high-performance service provider, WAN routing technology to interconnect clients without regard to access method or payload. All right, it supports a variety of client access methods, including Ethernet, DSL cable, frame relay. Right? MPLS can encapsulate all types of protocols. An MPLS router can be a CE, a PE, and a P. So I'll just go through those routers. Right? We have what we call a CE. And a CE, that is the customized router, which is responsible for, let me start, it's located on the customer side, and it is responsible for handling IP routing. So this one, don't need IP routing in the network. We are not yet on the label switching yet. So this one is responsible for IP routing. No label switching on this CE router. Then this one connects to our PE. And our PE is the provider edge router, which handles the transition between the IP and the MPLS domains. So I can call this domain the IP domain this side. Then this domain here is called the MPLS domain. So if this router is performing IP, is handling IP routing, this one is handling MPLS routing. So these ones are responsible for putting labels on the traffic coming from the CEs. Then lastly, we have the P, the provider routers. And these ones are located at the core of your service provider network and are responsible for forwarding MPLS traffic between the PE routers. So if traffic is coming from the CE, it goes to the PE, it gets encapsulated, that means it gets a label. Then that traffic goes to P, and P routes or switches that traffic to another PE, for example. Then de-encapsulation, it comes here, IP address, and it goes to its destination. So MPLS, I think, is very well used because it allows every protocol on this end, every protocol that you have on this end, when it comes here, it is encapsulated with a label. So it does not matter which type of protocol you have, different type of protocols, they can easily be integrated because here at the core, they are all using labels. Right, that's MPLS for you. MPLS provides QoS support, traffic engineering, redundancy, and VPN. I think another important use is also of VPNs. We'll get to VPNs in the later slides. 3 minutes. Right, internet-based connectivity. With internet-based connectivity, I think this one is common for everyone. We have your wired options, your DSL cable, then fiber, then cellular, satellite, and WiMAX. I think the next slide goes through one by one, starting with DSL, digital subscriber line. This is a high-speed, always-on connection technology that uses existing twisted pair telephone lines. So to provide IP services to users. So you see, the same telephone lines which we started with PSTN are the same telephone lines which you are using, which we used with ISDN, the same telephone lines we are using with DSL here. What differs is the technology which is being used to transmit information. With PSTN, it was analog. With ISDN, it became digital. Then with this one, it's still digital, but it is using frequency division multiplexing. I'm not so sure with ISDN which type of multiplexing was being used. Probably no multiplexing, but with this one, it was using FDM. That means more data is being pushed per unit second if compared to the other two, PSTN and ISDN. So it's still the same infrastructure used, but different technology or modulating techniques, if I can say, multiplexing techniques of data. When they differ, the speeds also differs. All right, so that is DSL. Then DSL, we have categories asymmetric and symmetric. With asymmetric, we have downstream bandwidth being larger than the upload bandwidth. Yes, it provides higher downstream bandwidth to the user than the upload. Then with symmetric, it provides the same capacity in both directions. If someone knows why the download speed is okay, let's say the downstream bandwidth is larger than the upload. Why? You can comment in the chat. Then DSL transfer rates are dependent on the actual length of the loop and the type and condition of the cabling. Okay, that's DSL technology for you. Let's go to DSL connections. DSL connections, service providers deploy DSL connections in the local loop. The DSL connection is set up between the DSL modem and the DSL access multiplexer. Right, I can see my time is up. I think let me end and continue from DSL. How many slides left? Hey, so, okay, we're still there. About 7 slides left. So join in soon after this one.